Okay, welcome to our last lecture. We're going to just be building on what we did last class, and this is going to be a pretty short lecture. We're going to be talking about regressions again, only now we're going to see how we interpret and run regressions with multiple variables and why we would do that. So the reason is based on this omitted variable bias. So right now what we have done last class is we looked at the student-teacher ratio as our only variable. All right, we said, how does the class size impact our testing performance? The issue is there's a lot of other factors besides class size that go into this. The first one that we're going to look at is California schools. There's a lot of Spanish-speaking students or students who are still learning English. Maybe that drives our findings. So how do we control for this? How do we address this concern? And how do we determine whether or not it is English speaking versus class size that's driving our findings? So why does English matter? Right, students who are still learning English might perform worse on standardized tests. And the reason is these are usually in English. They usually test things like your reading comprehension, things like that. It might take you longer to understand a question. So the question that comes up is, what if districts with large classes also have many students who are still learning English? In other words, how do we know if it's the large classes that are driving test scores down, or if it's the fact that there's actually a large number of non-English speaking students? That's what we're going to try and kind of tease out of this regression by including a couple of other variables. So this is what's known as that omitted variable bias. We've omitted a variable which is going to help us understand what's really going on, right? So if the student-teacher ratio is correlated or related to a variable that's been omitted, in this case, English learners, then we don't really know what test score is being driven by. Is it being driven by the variable we included, the class size, or is it being driven by students that are still learning English? And that is the omitted variable bias. We've omitted a variable that is introducing bias to our results. Right. And there we go. When the omitted variable is correlated with the included regressor, and when the omitted variable is a determinant of the dependent variable. Those are the more formal rules. But if you think it's going to have an impact on our findings, then it's likely to be something you should include in the regression. So there's a very simple way of first seeing what this relationship is. It's dividing our data. We're going to look at different subsets and see if we can see anything without even using a regression, some descriptive statistics approaches. So we're going to, instead of running a regression, we're going to try and hold something constant. And then we can see if we held something constant, what is the impact of a different variable? In other words, if we hold the student-to-teacher ratio constant, what is the impact of learning English? And how you do that is you can break this up into as many groups as you want. Here we have two. If we have a small class, we have our average test score of all those observations, 657. If we have a large class, we have an average test score of 650, where large is broken off by 20 students. But what we're going to do is divide all of these small classes further. What it shows very strongly here is that if you have a low number of people learning English, your test scores are significantly higher than if you have a high number. So that's telling us that within small classes, in other words, holding the student-teacher ratio constant, English does matter. If we do the same thing over here, large classes, we break it down, we find the exact same finding. So now what we can do is if we compare across these two groups, right? Now we say we knew that small classes had better grades than large classes. But what if we hold constant in this row, English learning? So we say everybody knows English. Well, those test scores aren't really any different. Or if we say most people know English, these test scores aren't really different. Come down here, a decent number are still learning. Well, we do find a little bit of a difference, and it does look like it's not significant though, right? That difference is about 5 points, but statistically, here's your t-stat. Remember, it's 1.96. It's not significant. And then if a lot of people are learning, we find the same thing. So really what this is telling us is that maybe the class size isn't what's driving our findings. It's that we have a different percentage or a different number of students who speak and understand English. Okay, so that prior table is known as a descriptive statistic, right? It's just a simple comparison. We have some descriptive statistics where you're comparing one group to another, just an average value. It's not a definitive answer though, and it's also very difficult if you have multiple things. So what if we also said income makes a difference? What if we also said age makes a difference? What if we also said, I don't know, weather makes a difference? Some other things that we think are going to impact test scores. Well, we can't keep dividing and dividing and dividing and dividing into smaller and smaller groups because it becomes prohibitively large, right? We can't just keep on doing that. So we are going to use a multiple regression or multivariate regression. So this looks very similar to our last setup. Y equals beta 0, which is our intercept, plus beta 1 times x1, plus, this is where it's new, beta 2 plus x2, and that can go on forever. We can just keep adding more variables as we see fit. The idea is, we come down here, beta 2 is the effect on y. If we view this in our test scores situation, beta 2 is the effect on test scores of a change in percent English speaking, holding our class size constant. So that's how you view these. These are the changes that these variables have on our test scores if you hold the other one constant. So in other words, beta 1, now that we have multiple variables, is the effect on test scores of changing student to teacher ratio while holding English language constant. Right, so really the interpretation is considering changing x1 by a change in x1 while holding x2 constant, right? We're really just saying this is the change from one variable, this is the impact of one variable changing while holding the other constant. And this is just another way of looking at it. Beta 1 is just your delta y, or your change in y, over a change in x1 to match your beta 1, holding x2 constant, and beta 2 is your change in x2, holding x1 constant. So these are known as control variables, right? Let's see, here we go. So I mentioned another one, maybe income, or consider how outside learning opportunities impact test scores. So there's, again, not just two things that could impact our results in terms of test scores. It's not just English speaking and its class size. Maybe we also think as a learning opportunity. Well, sometimes you can't even measure the variables that you want to consider. How do you measure outside learning opportunities? Well, what we need to do as researchers, as people who are trying to problem solve these issues, is, well, we can't measure learning opportunities, or at least not easily. What would be a good proxy or a good stand-in, a good measure that might capture the same thing? Well, economic background is probably pretty highly correlated with outside learning opportunities, right? The more money, the more wealthy you are, the more opportunities you have. So we're going to check the impact of this on our results as well. Okay, so suppose the superintendent proposed eliminating the reduced lunch program so that for her district, this variable would drop to 0. In other words, we're not going to help people pay for their lunches. The question is, would this boost your school district's test scores? Well, we can test all of these things. We can go through a regression with multiple variables and control for all these other characteristics to determine what's actually driving our finding. All right, and that's what this says. Coefficient on x1 is the effect on y, controlling for x2, right? We've talked about this, and we're going to actually go through the example with our our California test scores here in just a second. So the objective, and we're going to do this in Python, is to use multiple regression to mitigate omitted variable bias. In other words, to remove that concern that we've omitted variables. We must learn how to present our findings in an easy and interpretable way, and this is really what you're going to be doing in your final projects too. Okay, so focus, estimating the effect of test scores on a change in the student-teacher ratio. That is ultimately what this superintendent is proposing doing, is making smaller classes. If they do this, if this is done and it costs taxpayers money, they want to know that they're actually going to be improving test scores. So we need to hold constant other characteristics that are out of the superintendent's control. The superintendent cannot control how many people know English. They cannot control how wealthy their students are. They cannot control these things. So we need to control for them. We need to make sure they're included in our regression. So we're going to start with 3 variables: English learners, subsidized or free lunch, and California income assistance. So on their own, we're just going to plot, if you were to plot these, right? Test scores seem to be higher the more English speakers you have, or the lower percent of your students that are still learning English. Test scores seem to be higher the lower the percentage of students who qualify for reduced price lunches, or technically those who have more money. And the percentage of qualifying for income assistance, right? The more that are qualifying for income assistance, or the more that need help financially, the lower your test score. So it seems like all 3 of these variables are related to testing outcomes. So how would we want to set this up as a model? Well, we'd have our base model. We'd say student-teacher ratio. We've done this already. It's your single variable. We say, does this have an impact? It does. Great. Now let's control for some of our other variables. Does English learning matter? Let's add that in. Let's drop English learning maybe. Let's look at subsidized lunch in student-teacher ratio. Drop that. What about public income in student-teacher lunch? Then we can add them all in, so we can get these different models to see how these variables interact with each other. And with that, let's jump over to Python. Okay, so let's come up here, let's run everything. Only take a second, there we go. So here's that regression we ran last time. All the code above here is what I had already posted. Here it is. Your intercept, your small variable coefficient, where we had the dummy variable. Up here is where we had the regression with the actual student-teacher ratio variable. Okay, so let's rerun it. Regression 1. We've run it. Reg_1 equals our OLS. That's our variable test score and student-teacher ratio. We fit it. Okay. Now let's add another one. These are the variables that are in the data set. This is what they're actually called. So EL_%. This is your English language percent learning. This is your English language percent learning plus percent students on your meal plan. And this is your income. So if we run them all and we ask for a summary of number 4, this is what the regression looks like. Student-teacher ratio, percent English, meal percent, income. So it seems like student-teacher ratio does still matter. The larger your classes, the lower your scores. However, before we saw that the impact was 2.28 for an increase in student-teacher ratio, right? Grades went down by 2.28 points. However, once we control for some of these other variables, our grade now only goes down by 1 point. So the impact does still appear to be there. Look, we can see a significant t statistic, but the impact is significantly smaller, right? We've more than reduced it by half, or we've reduced it by more than half. The more English speaking people, or the more students who are learning English, your score goes down. meal percentage, more percent students who are on meal assistance, your score goes down. The more people who are on California low wage or your income assistance, yes, it's negative, but it's not significant. So that actually does not inform us about test scores. But what we have done is we've dealt with this omitted variable bias, right? We've got our variable on its own. We know that it does reduce test scores. We've controlled for some of the other characteristics we've discussed. So how would you present this in a paper or in a little write-up? Well, you'd want to present these results right here. But as I mentioned in the PowerPoint, you probably want to go through and do it one at a time to see how things are working. So let's just check it out. All right, so we might want to present the results here first. Here's the impact of student-teacher ratio. Well, what happens when we control for some of the other characteristics? Well, here's the impact when we control for English speaking. Oh, looks like this goes down quite a bit. What happens when we throw in a control for meal assistance? Here's our impact. Oh, once we put that in, it seems like we have these results. Once we put in the full model, this is what we have. So it kind of gives us a relationship between our variables of interest, student-teacher ratio, and how it interacts with the different control variables or the different possibly omitted variables from our sample. So that's really all there is to our multiple regression. You can go ahead and practice this. I'm going to post the code and everything. You're essentially going to be doing this and tying everything together for your final project, which is online now. If you have any questions, let me know. But honestly, if you can get through this assignment here, or this isn't really an assignment, but this set of code, you understand what's going on, and you followed along throughout the course, everything that you're going to need to do in that final project is stuff you've already done. It's just a larger data set. And really, the only thing that might be different is how long it takes in terms of your computing time. Right now, everything you've done has essentially worked instantly. It's because they're very small data sets. You're going to be working with a much larger data set this time. So when you run a bit of code, instead of expecting it to happen immediately, wait a couple seconds. You know, things are still running. You're going to be processing a lot more data, so it might take your computer a little bit longer to run, but it shouldn't be too bad, and you guys should be all set for that final project. Thanks, guys, and let me know if anything comes up.